Hey YouTube, J. Corey here, back at the Saunders Machine Works Deluxe DeWalt saw base. You notice I've taken my saw off that I mounted in a previous video, and the reason is I took these two items off of the factory base, and I want to get them to work on here and make it kind of removable to where I can add these items, the screw vise, the shoe, all this. I want to make it to where I can use these items on this base and then quickly and easily remove these items from this base when I don't need to cut angled cuts. Be aware that if you take this piece of the fence off, you are going to have to basically square this, tram this in with this surface when you're back. It's not pinned, and there is a little bit of play around the bolt holes, so you are going to have to do a little work to straighten that back out. I've already marked on here where the fence is going to mount. That's already marked. And then the screw is going to mount here along the center line of these slots, these holes, and these 4 holes here are going to become a slot. We're going to mill this out larger, and then we're going to cut all this out. These are 0.625 diameter. We'll have to make us a new pin to hold the fence here, the jaw for the screw clamp, that's going to have a diameter that's going to be larger here than 0.625, so we can cut a slot in it, just drop it through this hole, and then it'll slide in this slot and keep it from lifting. So we're going to have to make a new pin and modify this to have a larger diameter. So we're just kind of doing all this on the fly. So let's get it set up in the mill. We'll start with these holes here. These are going to be drilled and tapped for 10 millimeter by 1.5 millimeter pitch, and that will mount the fence, and then we'll do this next. So let's get with it. Alright, so we got the table up here on the mill. I just ran a couple of studs up through this slot here, all the way through the clamp holes in the table, and clamped it down that way. Then I got a toe clamp over here on the flange here of this little piece of C-channel, and it's securely mounted. So we're going to get a drill chuck in here, and we're going to go ahead and drill and tap the 10 millimeter by 1.5 tapped holes for the fence, and then we're going to have to spin this thing around just because of travel issues in order to do the hole here and the slot. So let me get the drill chuck swapped out. Okay, I could probably use maybe the next thing I investigate out of the Saunders Machine Works catalog is that power drawbar setup. I've got two risers on this mill, so I can't reach the top of the drawbar without a ladder. All right, I just spotted with a carbide spotting drill. These things are great. And the reason it's carbide is because I don't want to have to worry about stainless steel or other types of materials that'll cut through anything. 8.5 millimeter is the tap drill size for a 10 millimeter by 1.5 pitch bolt. I zeroed my X on my DRO there so I can come back to tap that hole. Ready? Put it over there. Whoop. Before we tap, we're going to throw a generous countersink on there. Kick it over into back gear. Let's get our tap. Let's tap the hole. gun tap for a through hole. I really only keep about two kind of taps around a lot. It's gun taps, spiral points, and spiral flutes for doing blind holes. So all right, we got the table turned around in the mill, got it clamped back down. First thing we got to do is we got to enlarge this hole so that when I set the shoe down, it can slip in and then grab this slot we're going to cut. This will have to be bigger. Unfortunately, right now this is 15 millimeter. It just sits right in there. This pin, the size of the pin up here at the top, all right, the pin that holds the shoe on the screw clamp at the top is 8645, which works out to about 22 millimeters. So that's our maximally, if I make this pin just straight through, then this hole will need to pass 22 millimeters, which means I need to do that hole maybe an inch, and that'll give us plenty of working room there. So what I did is I stuck a 5/8 inch drill in here, and then we're going to use this to line up our existing hole. There we go. Lock down my X, lock down my Y. Now we'll swap this out for the 1 inch. Let's get some A-bomb approved cutting oil here. Still driving around a little bit. I think I need to increase the tension on my my hold down. plenty hot. Cut 2 nice chips there, so that is fresh. I don't know if I've ever used that. It's a set of Triumph Twist I bought on sale from Inco back when they were still Inco, and it was I think Adam Booth had turned me on to that. It was a great deal. All right. So the pin's going to drop in here, and now we're going to cut a 5/8 inch slot from this hole all the way back here. I'll go ahead and get my tooling changed around, and then I'll come back. Okay, we swapped over to an end mill here. This is Niagara, 4 flute, high-speed cobalt, medium rougher, I believe, square point, 5/8 inch, and it is coated, as you can tell. This is one of the end mills, so generously gifted to many of the YouTube guys by Niagara at last year's bash, and we're going to put that baby to good use right now. We're going to cut this slot right here. All right, there we go. So we have our slot milled here now. The Niagara end mill worked out fantastic. You just got to make sure and feed them fast enough. Suggested feed for this mill right here is, at this size, is 4 thou per tooth per rev. So 4 teeth, you know, there you go. You can do your calculations yourself. All that's left to do right now is to drill and tap the 2 holes here that will hold the screw clamp portion base down. I'm just going to take this off of here, move it back over to where it goes, and we're going to position that and do that the old-fashioned way. So let's just hand drill it and tap it, and then we'll be good to go. Then we've got to make our pin. All right, so we're back over here. Our slot is milled, our holes. This is mounted using the, you're probably asking why I used metric tap, because it came with metric fasteners, and they were actually quality fasteners. So what I did here is I took a square and I lined up on my slot, and I chalked out the center line of my slot, and there's actually a bolt right there that bolts up through the flange to hold this top on, which we will not interfere with in any way. So this is where it needs to go. Now, the factory installation, this bolted up through the bottom of the base. It wasn't designed to be easily removable or removed at all, for that matter. I, on the other hand, want to be able to bolt it down from the top. I don't want to have to dig around under the base or anything like that. I want to make it as easy as possible to remove this entire setup. So we're going to have to modify this a little bit by milling these flat. They've got a slope to them. We're going to have to mill these flat. We're going to have to over drill these threaded holes to pass hardware to hold this on, and I believe these are some 6mm socket head cap screws that were used somewhere else on the base, and so we'll use these. No use in, well, they held this on, but there's no use in wasting quality hardware. So what we're going to do is we're going to flatten these shoulders. We're going to drill a passage hole for this 6mm bolt, and then we're going to tap 6. Pretty sure this is 6 by 1 1/4, 6 by 1, and we're going to tap the base. We'll drill and tap the base to take these screws directly from the top rather than from the bottom. And then at that point, the only thing left to do at that point is to modify the pin and the shoe to work with this slot. Or actually, we're going to make a new pin and modify the shoe to take it. So let's move back over to the mill, and let's do what we need to do with this, and keep on moving on.